Hey, Professor Capps, it's Michael James here presenting on nuclear bombs for the interactive advanced concept number 6. So, nuclear bombs are weapons of mass destruction. We've seen them used in previous world wars, and they harness forces that hold the nucleus of an atom together by using the energy released when the particles of the nucleus are either split or merged. Uh, Nuclear bombs use the energy that's produced from chain reactions. So the energy released in a nuclear explosion derives from the fission of radioactive materials. Now, these radioactive materials are usually uranium-235 and plutonium-239. If you notice, these radioactive materials are going to be rather large. In order to understand the capacity of energy that a nuclear bomb releases, it's critical that we understand the basic components of an atom. So all matter is composed of atoms, which are small structures that house different combinations of protons, neutrons, and electrons. At the center of each atom is a nucleus, which is where the neutrons and protons are bound closely to each other. Now, most nuclei are stable. During fission, the nuclei of heavy atoms, like in uranium-235 and plutonium-239, split into smaller, lighter nuclei, which releases excess energy in the process. In the nuclear bomb, the splitting of the nuclei is induced from the outside. The neutron is shot at the nucleus and is absorbed, which causes instability and fission. The fission process also releases excess neutrons, which can trigger a chain reaction when they are absorbed by nearby atoms. Fusion is the opposite of fission, but it still produces very much energy. So when exposed to very high temperatures and pressures, the lightweight nuclei fuse together to form heavy nuclei, which releases energy in the process. So the modern nuclear weapon uses both fusion and fission to release explosive energy. Nuclear weapons use fission to generate the explosion. Modern nuclear weapons detonate chemical explosives around a subcritical pit of either uranium-235 or plutonium-239 metal. The force from the blast is directed inward, which compresses the pit and brings its atoms close together. When the pit is dense enough to reach a critical mass, neutrons are injected, which initiates the fission chain reaction and produces the atomic explosion.